Today we are going to solve the problem 2.42 of Griffith third edition Introduction to Quantum Mechanics in a very simple manner. In problem 2.21, you analyzed the stationary Gaussian free particle wave packets. Now solve the same problem for traveling Gaussian wave packet starting with the initial wave function psi of x and 0 is equal to a e power minus ax squared. Last time we have seen only these two terms. Now this is the traveling wave. E power I Lx, where L is the wave number, uh, X is a position, L is the wave number. So, before going into the detail of this lecture, please refer my lecture on problem 2.21, in which we have solved A is equal to 2a over pi whole power 1 over 4. Then, in order to find the time-dependent wave function psi of x and t, we need the wave function psi of k. Of course, this is the amplitude of wave modulation. So, this is called Fourier transformation, which is equal to 1 over square root of 2 pi integral minus infinite to plus infinite psi of x and 0 e power minus I kx dx. Now, you know the psi of x and 0, this one, is equal to, which I have shown in yellow color band. That is, this is normalization constant, and that this is the wave function at t equal to 0. Now I am multiplying same by e power minus ikx dx. Now we got this expression. Uh, Now I am going to rewrite this as exponential minus this ax squared, because I have taken minus outside. This minus k will become plus k. So plus ik minus L. This plus L will become minus L. I have informed that L is the wave number. So multiplied by this X. Now we have seen in detail in my lecture on problem solving the problem 2.212 that this is the Gaussian integral. If the integral is of the form minus infinite to plus infinite, e power minus ax squared px dx will be square root of pi over a e power p squared over 4a. Here p is the coefficient of x. P is equal to coefficient of x. So which is here in our case I multiplied by k minus L. So what about A? A is coefficient of x squared. Coefficient of x squared. So here it is simply A. So you substitute it here, then you keep this term as it is, and square root of pi by A. This p squared is this one. I multiplied by k minus L whole squared will become I squared is minus 1. So minus k minus L whole squared over 4a. A is the coefficient of x squared. So now we can cancel some of the term. So what will happen? Straight away this pi and this pi will get cancelled. You bring this a inside, it will become a squared because it's the square root. This one is 1 over 4. So similarly, this will become 4. So here this 4, uh, of course, I have brought this here. And 2 also I brought inside, which will become 4. This a will become a squared. So now this 2 and 4 will get cancelled, you will get 2, and a will get cancelled with this a squared, you will get just a. So this constant term will become 1 over 2 pi a whole power 1 over 4, and this exponential term. This is the pi of k, which is the amplitude. So we got psi of k is equal to 1 over 2 pi a power, whole power 1 over 4 e power minus k minus l whole squared over 4a. This is the Gaussian distribution. The This is called Gaussian distribution, centered at L, k equal to L. It is centered at k equal to L. So now you can take the Fourier transformation of this. That is psi of x and t is equal to, by definition, is 1 over square root 2 pi integral between minus infinite to plus infinite psi of k e power I kx minus omega t. So here you replace pi of k. Pi of k is this 1 over 2 pi a power 1 over 4, and this exponential term. And here I'm going to replace omega is equal to, we have seen already so many times, h cross k squared over 2m. So I have replaced h cross k squared over 2m multiplied by 3t. We are going to integrate with respect to k. Now we got this integration. This integration you can apply the Gaussian technique, and after apply the Gaussian technique and after simplification, you will get this. This constant also we are going to modify it based on this integral value. You can simplify all the constant and you will get 2a over pi whole power 1 over 4, 1 over gamma. Gamma is square root of 1 plus I 2 h cross at over m. So here you can see, uh, you can find the group velocity, that is this is the Gaussian wave. This x squared whole squared is a Gaussian wave. I will use different color. This is Gaussian wave. As I said, this is centered at L. So this is the Gaussian and modulated by this complex phase factor. This is the complex phase factor, complex phase. So what is the group velocity here? Envelope velocity. This is the Gaussian envelope. So here you can see HL over M. HL is the momentum. L is K. L is having dimension of number of wave per unit length. So wave number. So it is equal to momentum, mass into velocity divided by mass. This is the group velocity, and it is modulated by the phase velocity complex factor. Here you can see this is a HL over 2m. So we have proved naturally the phase velocity is half of the group velocity. We have seen in our lecture on theoretical lecture on quantum mechanics. Thank you very much for watching my videos and supporting me continuously. Thank you very much.